Right. So, Chapter 8. So, Chapter 8 deals with right triangle, trigonometry first. So, we have our basic right triangle. So, A, B, C. Side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So then we have in terms of our trig functions, so sine theta, which is opposite over hypotenuse, which in this case will be A over C. Cosine is adjacent over hypotenuse, which will be B over C. So let me put my theta in here. All right. And then tangent, which is opposite over adjacent, which is going to be A over B. And those are the main three, but then each one of these three, there's also the reciprocal function. And so we have cosecant, which is hypotenuse over opposite, which is C over A. We have secant, which is hypotenuse over adjacent, which is going to be C over B. And then we have cotangent, which is going to be adjacent over opposite, which will be B over A. And those are the 6 trig functions. Right? The 3 you'll find easily, should be able to find easily on your calculator will be sine, cosine, and tangent. Okay? So let's say we're given something like this. So given that A is 3, B is equal to 2, and we want to find side C, angle A, angle B. So let's first draw out this triangle. I always look something like this. This is going to be 3. This is going to be 2. Here's my right angle. So this is A, this is B, and this is C. Right? Right. Well, let's see. Let's first find our hypotenuse. So everybody should hopefully remember this. A squared plus B squared equals C squared. So the good old Pythagorean theorem. And so you'd have 2 squared plus 3 squared equals C squared. So 4 plus 9. So C squared equals 13. So C is going to be the square root of 13. Right? So we know what C is now. So let me put that on my triangle. Right? And now we need to find our angle. So let's find angle A first. Right? So the tangent of A is going to equal 3 over 2. And we want to find angle A, and so angle A is going to be the inverse tangent of 3 over 2. And so you could plug that in on your calculator. And so you should see right above your sine, cosine, and tangent buttons on your calculator. You should see where there's a sine -1, cosine -1, tan -1. And that's what we use when we want to find the angle. And so here, this will come out to be 56.3 degrees. Right. Well, in a triangle, we know that angle A plus angle B plus angle C has to be 180 degrees. Right? So we know A, we know C, and so 56.3 plus B plus 90, 180. 146.3 plus b equals 180. And then we could just subtract. And angle B is going to be 33.7 degrees. So we found what we were looking for. All right. Other types of problems you'll see will be ones like these, so word problems. And so if the angle of elevation to the top of the building, is 62 degrees, and the person's line of sight is 6 feet above the ground, and they are 40 feet away from the base of the building. All right, from the base of the building. Okay. So the question then is, how tall is the building? Here. All right. So let's draw a picture. So we have our building, right? We have our person, right? And so this person is here, and we know from here to here is 40 feet, right? And they're looking up to the top of the building. And it says the angle of elevation. So angle of elevation is looking up, right? And this is 62 degrees. Right? Okay. And we want to know the height. So we're going to get this number right here, okay? But we also know that the distance from here to here is 6 feet. Right? So we want to get the height of this building. So if I look at what I know, I got the opposite side, I know the adjacent side, so this is going to be tangent. So the tangent of 62 is going to equal h over 40. And so h is going to be 40 tan 62. And that we could plug in, and this number comes out to be 75.2, right? And so the height of the building is going to be 75.2 plus the 6, so we get 81.2 feet for the height of the building. Well, that's right triangle stuff. Well, then the chapter talks about other type of triangles, so oblique triangles. So these are either going to be acute or obtuse. Okay? So you got a few laws that you're going to talk about. First one is the law of sines, which is A over sine A equals B over sine B equals C over sine C. Okay? So let's look at a few examples here. So let's first solve one of these, ASA triangle. So this is angle, side, angle. We know what that means. So let's say we have A is 100 degrees, B is 43 degrees. And C is 12. Right? Well, in order to solve a law of sines question, you need to have an angle side pair. Right? So we need an angle side pair. What that means is we need to know either angle A and side A, angle B and side B, or angle C and side C. Well, right now we don't have that, but we have enough information to do it because we could quickly figure out angle C. So angle C is going to be, because after all, the sum of the angles on a triangle is 180. So angle C is going to be 180 minus those two. So angle C is 37 degrees. So we got that angle. Right? So now we can find our other two missing sides. And so let's do 12 over the sine of 37 is going to equal A over the sine of 100. And we're going to cross multiply divide. So A is going to be 12 sine 100 over the sine of 37. And so side A is going to be 19.6. And then we can do the same thing and find side B. So 12 over the sine of 37 is going to be B over the sine of 43. And again, cross multiply divide. And so B is going to be 12 sine 43 over the sine of 37. And that'll give us 13.6. Okay. So we found everything in regards to that triangle. Right? So let's look at another type. And this is now going to be solving side-side angle. So we need to look at this one. And what does it mean? This is H. Here's my angle. This is B. This is A. Right? And so the height of the triangle is given by B sine A. Okay? And so what could happen here is there are several possibilities. So the first case is if H is greater than A, then no triangle. If H is equal to A, then a right triangle. And the third possibility, if H is less than A, then two triangles. So let's look at an example of how this would work. So let's say A is equal to 6, B is equal to 8, and angle A is 35 degrees, right? Now the only time we have to worry about this whole two triangle possibility scenario is if the opposite side, and so opposite side means of my given angle, which in this case is 6, is less than the adjacent side, which in this case is 8, which is true. So when this is true, the first thing we need to do is find the height. So the height is going to be given by 8 sine 35, and this comes out to be 4.6. So we have two possible triangles. All right, so now we're going to divide this up into two cases. So let's do first case 1. And so we'll have 6 over the sine of 35 equals 8 over the sine of b. Again, cross multiply, divide, and this time we take the inverse sign because we want the angle. So b is going to be the inverse sine of 8 sine 35 over 6. So this will give me 49.9 degrees. Okay. And then, of course, the other angle is going to be 180 minus the other 2. So 49.9 plus the 35. And so this comes out to be 95.1 degrees. Right? And then we can find side C. And so 6 sine 35, 6 over the sine of 35 is C over the sine of 95.1. Cross multiply, divide. And so 6 sine 95.1 divided by the sine of 35, and this gives us 10.4. Right? Well, now how about the other triangle? Right? So let's do case 2. So case 2. Right? So what we do in case 2 is, first off, well, the first angle I found in case 1 was B, which is 49.9 degrees. So in case 2, the new angle B is 180 minus. And so this number comes out to be 130.1. And then angle C is going to be 180 minus the other 2. And so this is going to be the 35 and the 130.1. And so this will give us 14.9 degrees. That's my two angles. And then we can find the missing side. So 6 sine 35 equals C over the sine of 14.9. So C is going to be 6 sine 14.9 divided by the sine of 35. And that gets us to 2.7. So that's everything in regards to my two triangles. Well, how does this work that we could have two triangles? Well, what's going on here is this. So let's make a drawing. So this is my 35 degrees. Right? This number is 8. We figured out that our height was 4.6. So this number was 4.6. Right? But then side A was 6. So side A could be going like this. Right? But if you think of that up there in that corner as being a hinge here, right here, if that's a hinge, and you think about this being able to swivel, well, I could have had A go like this, but I could also have A going like that. And that's why we end up with two possible triangles here with that. All right. Well, that's a lot of sines. Right? And so we then get into a lot of cosines. And so here we get c squared equals a squared plus b squared minus 2ab cosine of c, or b squared equals a squared plus c squared minus 2ac cosine of b, or lastly, a squared is b squared plus c squared minus 2bc cosine of a. So those are the three possible ways I can write it. Okay. So we use log cosines if we are doing either a side problem or a side angle side problem. Those are the two where we're going to use this. So first off, let's do side angle side. So S, A, S. So given something like this, A equals 8, B equals 13, angle C is 75 degrees. So the first thing we do, step one, is we're going to find the side opposite the given angle first. Okay. Which in this case means we're going to find side C. Okay. So we have C squared equals 8 squared plus 13 squared minus 2 times 8 times 13 cosine of. Right? So what you should be able to do is just say C is going to be the square root of all of that stuff. Okay? So you should be able to do all of this directly just right on the calculator. Right? And when you do that, you'll get this is going to be 13.4. Right? All right. So now we have a side. Now we can actually go back to using my law of sines. So step 2, we're now going to use law of sines. And we're going to find the angle opposite the shorter of the two given sides. Right? So that would mean here is I'm going to find angle A first. So 8 over the sine of A is going to be 13.4 over the sine of 75. Cross multiply divide, take the inverse sine. A is going to be the inverse sine of 8 sine 75 over 13.4. And you plug this in, you get 35.2 degrees. And then, of course, we could find angle B, because angle B is going to be 180 minus the other two. And angle B is 69.8 degrees. All right. So that's the process given that, all right? And so again, you find the side opposite the given angle first, and then you can use law of sines to find the angle opposite the short of the two sides, right? So, or the other way, you could do law of cosines again if you wanted, but law of cosines is a bit more work, I think. Right? So the other case then is this. Solve S, S, S. So here, the first step is to find the angle opposite the largest side. Okay. So if I'm given something like this, A equals 8, B equals 14, and C equals 17, right? Well, that would mean in this case, I'm going to find angle C first. And so we're going to have 17 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 cosine of C. Well, we start doing this out. This is going to be 289 equals 64, 196. This will be 224 cosine of C. So 289. And this will be 260 minus 224 cosine C. Subtract the 260. And so 29 equals minus 224 cosine C. And then we're going to divide and take the inverse cosine. And so we get the inverse cosine of 29 over negative 224 equals C. And angle C is going to be 97.4 degrees. Right, so that's the first thing we do. And so now the second step is use law of sines to find either of the two remaining angles. So we can now go back to using our law of sines, and so we could have 8 over the sine of A is equal to 17 over the sine of 97.4. Again, cross multiply, divide. Take the inverse sine. And we get A is 27.8 degrees. Which means then, of course, that angle B is 180 minus the other two. And so angle B is 54.8 degrees. All right. The next thing the chapter talks about is area of a triangle. So remember in your basic geometry class, you probably learned area is 1/2 base times height. Now, we can write this out a few other ways, and that is the area is 1/2 AB sine of C, or area equals 1/2 BC sine of A, or area equals 1/2 AC sine of B. So you have given something like this. So A is 70 degrees, B is 12, C is 8, and so the area is 1/2 12 times 8 sine of 70, and you get 45.1. All right. Another way is a thing called Heron's formula, and that is given by this, that the area is the square root of S times S minus A times S minus B times S minus C. And S is equal to 1/2 A plus B plus C. So let's look at an example of this. So let's say A is equal to 4, B is equal to 5, and C is equal to 7. So S is going to be 1/2 4 plus 5 plus 7. And so S is going to equal 8. So my area is going to be the square root of 8 times 8 minus 4, 8 minus 5, 8 minus 7. Okay. But then, of course, this is just 4, this is 3, and this is 1. And so we end up having the square root of 96. And this is basically 9.8. And then the last things the chapter finishes off with is in terms of harmonic motion. So simple harmonic motion, or SHM. And so you have either in terms of this form a cosine omega t, or the change in time equals a sine omega t. Okay? And so theta is omega over t, or omega is the angle over t. Okay? The frequency is 1 over the period, which is given by omega over 2 pi. And so the period is 2 pi over omega. So you're barely given something like this. So dt equals 10 sine 5t. Right? Well, the amplitude is 10, and the period t is going to be 2 pi over 5 seconds. And the frequency would be 5 over 2 pi, and this would be oscillations per second. And then the last thing to figure out with this is called damped harmonic motion. So now we have this. Okay? So let's first go back to my simple harmonic motion, and what are we talking about here in terms of a graph? Simple harmonic motion basically will look something like this. It's basically just going to be your sine or cosine curve. Is simple harmonic motion. Okay? Whereas damped harmonic motion is going to look something like this. You're going to go up and down, but then you're going to be decreasing the amplitude as time goes on. And so here we have this formula. dt is equal to AE M cosine. Let's see, omega squared minus b squared over 4m squared, and t. And let me get rid of some of this. Oh, yep. Right. Of course, this whole thing. So we want to do just to there. All right. And that is my formula for damped harmonic motion. Right? And that will conclude this video.